Brett Sarmento, going to talk a little bit about cooling towers and the filtration equipment that's out Energy Center. Company is Sarmento Mechanical Sales. Now, here's where the connection with your humidifier comes in. End of the season, turn the heat off, turn the air on. Do you guys ever look at that media, that part of your humidifier? And if you pull it out, you look at it, it's all crusty, right? It's a bunch of minerals. If the evaporative process happens, you drop out of suspension the dissolved solids. They collect on the pad. Same thing happens in the cooling tower. That's why you do a blowdown, right? The water treater is going to do a blowdown. Have we had owner training with the water treater yet? They have a process as part of the water treatment that periodically they do a blowdown. They get rid of some water and make it up with clean water, concentration of dissolved solids under control. If that gets out of control, what ends up happening is you look at the outboard face of the cooling tower, the fill material, and that's where you start having those dissolved solids drop out of suspension, right? You guys won't see that probably, but in older towers where the water treater hasn't done it, or the owner maybe has said, we don't want to blow down to the degree that you think we need to, you could find that for me. That's time to call Du Bois, whoever is out doing your water treatment. Reason I bring this up. So each cell cools 2,250 gallon a minute from 95 degrees to 85 degrees at a 77.78 degree wet bulb. I bring this up, we had some cooling towers replaced at a facility in Metro Detroit, and a year later, I get a call from the owner, and he says, Brett, it took me 45 minutes to get to the bottom line here. Brett, your cooling towers aren't working properly. I said, what? So keep in mind, this whole conversation, I'm trying to be gentle. Owner's always right, customer's always right. I said, after 45 minutes, I said, Joe, what's the temperature of the condenser water going to the chillers? He says, 79 degrees. He says, I need it to be 78 or lower, or the chiller goes off on high head. And I said, Joe, cooling tower is only going to deliver 85 degrees water on a design day. You have a condenser problem. If the cooling tower is making 85 degree water, and you're probably set up, the control system probably has it set up to make colder water than that, and it's able to do that almost the entire year. However, on a design day where the chillers are running fully loaded and the wet bulb temperature is 78 degrees, we're going to get you 85 degree water. This isn't going to happen probably in our lifetime either. However, as condenser water systems get older, the carbon steel pipe develops pipe scale, right? On top of the cooling tower is what we call the hot water basin. There's two on each tower, each cell. And so the warm water comes in, just essentially dumps into the hot water basin, and then by gravity flows over these distribution nozzles, right? And the nozzles will end up plugged. The solution to that is, on top of the fan deck, this is after you lock out the tower, pull the hot water basin covers off, and reach in and pull the scale out of the nozzles. Now, what you don't see in those nozzles is this little target thing. So as that water comes down through the nozzle, it hits a target, splashes, hits another target, splashes. A lot of people go up there with a long flathead screwdriver and just jam the fill material of the scale down. Don't do that. You'll ruin that distribution nozzle. And then what you have is this beautiful stream of water going straight down like a laser through the fill material. You have a direct drive fan system. It's called the Endura Drive fan system. So we have a fan motor, shaft up, and the fan assembly is directly attached to it. It's a permanent magnet motor. It's not an induction motor. You're going to need to grease the bearings every 15,000 hours of operation. Work that math. You won't be in there, right? Nothing to do with that fan motor for the next several years. Inside the mechanical room are the VFDs that control the fan speed. But the point is, it's not like a gearbox. Most of your cooling towers you will see will have either a gearbox or a banded belt drive that either need to have the oil changed or bearings greased or belt tightened. None of that's required. I did put in here the link to the owner manual for the motors and the VFD. And then Ron Weiss is the point of contact. He starts up almost every ABB drive made to man in this region. I don't know if we have other ABB drives that are in the hospital proper, but if so, Ron's probably been out to start those up. There's his contact information. We've got electric water level control probes that periodically need to get wiped. I did say if you're going to be on the fan deck pulling scale out of nozzles, you're going to lock out the fan. The proper procedure to do that won't be to lock it out at the tower necessarily. I would suggest you hit the stop button on the drive in the powerhouse and then go out and throw the disconnect switch. Let the fan stop on its own and naturally. If it's an emergency, absolutely throw the disconnect switch. But generally speaking, it's not going to be an emergency if you're doing routine maintenance. If we wanted to raise the water level, we have to cut those probes. They are a beast to cut. So I've done it using hacksaw. I've seen a Metabo used. So each cell has a vibration cutout switch so that if we do experience excessive vibration, it'll lock out the fan motor and you'll have to go in and reset it. Before you go to reset it, you lock it out. You go out there and you look and see what caused the vibration trip. Is it because maybe one of our props is got this kind of pitch to it, all of a sudden went like that? Probably not. Is it because a pigeon got caught and dinged a prop? Probably not. For whatever reason, somebody wants to make 40-degree water. So if you envision, you've got air going this way, water going this way. So this outboard face is seeing really crazy cold water or air. And the inboard face, not seeing, by the time it gets here, it's warmed up a little bit, saturated, so you're not evaporating much water. So to get 40-degree water out of this blend, this is going to be 40, maybe this is like 33, 32. So off that air inlet face, you're going to build ice. You don't want to build ice. You allow the water temperature to build, you turn the fan off. Let the water temperature increase to something more reasonable. I don't care. 70 degrees, run the fan in reverse, 30 hertz. And now what you're doing is you're taking that cold air down through the fan, out through the fill material, and it's picking up heat as it's going. Should only take about 20 minutes unless you're really late getting to the de-ice procedure. What you have is a single cell tower and a 2-cell tower. I don't know how you've designated CT1, CT2, CT3, but there does need to be clearly some coordination. If CT1 is or CT3, let's say, is the one that's online, CT1, CT2 are drained, and now you need more cooling. Well, you need to have CT1 and 2 full of water before you can turn a condenser, open those motorized valves, right? That I don't know how automated that is through the control system. Condenser water system has a filter, and that doesn't show it. On the chilled water system, any solids that we collected, we'd continually purge to what we call a solids recovery vessel. It's a glorified name for a bag filter. So I fired up that system first, made sure that we had a pump rotation and pressure drop and blah, blah, blah. Go over, start the condenser water system, and everything's working fine there. Come back to the chilled water system. I call the owner over. I said, I want you to look at this. And so we isolated that bag filter. Keep in mind, chilled water system in place for 20 years and operating for 20 years. Open up the bag filter, pulled the bag out, 20 pounds of debris came out of the chilled water loop. So that's what this thing does. It removes solids down to about 45 microns, which is about the size of a speck of talc. Very small. It's not a sand filter, so we're not pulling it down to 5 microns or 2 microns. Butterflies, we're pulling in dirt and dust and everything else. We're not trying to get it to a quality where we can drink it, but it will pull out the dirt and debris that's going to cause the fouling in the condensers of the chillers, right? It is side stream, so it's filtering a lot of water and getting a lot of dirt and debris. In your case, it's equipped with a motorized ball valve, and so it's set up to blow down for about 20 seconds every 12 hours. There's nothing to do here except occasionally grease motor bearings. So we want to keep the velocity up to drive the solids. The solids end up going this way. There's a plate down here, and the solids ultimately drop out down here, and that's where they collect until it gets purged. The clean water comes right back up through the center, and it's pretty cool to see. We've got a little, the key part of that is, in 4 years, how often had that spray water system been cleaned? Biocides or biological growth was dirt, debris, and crap, right? Because if it's down here and you got a bunch of crap up here above it, that's the food source, and that's like protection against any biological biocide you put into the water. So how many cooling tower cells do you think are installed at University of Michigan? Is that because they've got good PR and they keep it under the rug? Oh, heavens no. No. But they do have a good water treatment process, and they keep their cooling towers clean. That's really the key. Really, absolutely key. So she goes to this job site. It's an industrial site, and gets to maybe 30 feet away from this cooling tower, and it smells like an outhouse. And she stops. She says, you guys, you got to clean the cooling tower. And when you do, I will come back. If it smells like an outhouse, do something about it. Call somebody, right? Shouldn't smell like an outhouse. Now, it's not going to smell like a swimming pool either. It's not going to, it shouldn't smell chlorine to that level. So far, we haven't really talked about cooling tower, but it's, you got to be in it, on it, around it, lock it out. If you make good friends with a water treater and you see that person here on a monthly basis, great, and keep it clean. BAC suggests cleaning it twice a year. So you're going to find dust, dirt, particularly the proximity to the expressway. You're going to get a lot of airborne dust and dirt that collects in that on the floor of the cold water basin of the cooling tower that you're going to need to clean. So we supplied some cooling towers for a development on the river in downtown Toledo. That development ultimately has gone through some changes over the years, but it had been laid up for like 4 years, 5 years. It's a simple process. So I swear to you, I think it was like 107 degrees and 15% relative humidity. And under those conditions, you can make, I haven't done the math lately, but I think it's like 75 degree water out of a cooling tower. Here's your separator, your filter. I don't know why it's not running right now, but it's not. It draws water off the system, side streams it, does the centrifugal separation, solids collect in the bottom, clean water goes back up and out. Purges to that drain right there. Anytime a condenser pump's on, you should have, I'd run this. Right now, the disconnect switch is off, yeah, and the handoff auto switch is off. So normally we have a gauge here. There is a tap here, and obviously they're monitoring the pressure differential, although we're isolated here and here, but it looks like it's tied into the building management system. 12 would be the top end for the separator, where if you can get to 12, that'd be ideal. That's where you get the highest velocity. We're running it at design flow and getting the best performance out of the separator, getting those 45 micron particles removed. It's a novel way to do this on multi-cell cooling towers. So level control's right here, and it's measuring the water. So back up the horse. Multiple cell cooling towers that share a common suction header have to be what's called equalized. So the water levels are all the same all the time through the equalizer line. This is tied into the equalizer line. So periodically you're going to need to pull that and clean it. The little flash, the LED here is solid red, all good. There's little error codes that are on the side of this. And this has a call for makeup water. Solenoid valve inside introduces the makeup water into the suction header. So again, if we're running 2250 GPM out of the tower, if you're going to be putting your hands in the water, keep in mind it's chemically treated. I would suggest wearing rubber gloves. I would suggest washing your hands shortly after getting out of the tower. On the tower, you lock it out, all right? This tower's not running. Oh, we're going to lock it out. No lock, but we're just going to look in. That's all we're going to do. Oh, I lied. It was running. Let's turn it back on. Some people aren't thrilled about rotary disconnect switches. Well, that's a good question. I don't know where that would take place. There's no service switch out here, so I don't know. You're not going to have it out of the water that long. All right, so let's throw the disconnect switch on the fan motor to this tower. You do have internal walkways, so you don't need to wear boots. Generally speaking, it probably is a good idea to come out here with somebody else. You never know. If you go in there, you don't have a hard hat on, you hit your head and boom, knock yourself silly, fall in the water. The potential exists. That would not be a positive outcome. So perhaps have somebody else out here, or be really careful when you're going into the tower. If we were to go in right off the gate, here's a headbanger. Right? So want to avoid that. Vibration cutout switch is mounted right beneath the motor. Can't miss it if you went in there. And it's just a simple push button. You can reach it without a ladder. So BAC came out with the single inlet piping connection about 92, 93. I'm sitting with a consulting engineer, and it works really great. A much cleaner installation, but what you have is symmetrical piping from here, so you end up with balanced flow. The overhead piping, there's an expense to that. There was another installation where 3 cells just like this, design build, but the contractor took some shortcuts. The piping ran all the way down into 1 cell, no valves, none, 0. And I about crapped a brick. I thought, how are you getting balanced flow on cell 1 and cell 3? Detect any difference in level in the hot water basins from one tower to the other.